All right, so just like some logistical stuff, obviously this is covering from chapter P all the way through to 3.4, where we ended. The 3.4 was like the higher degree stuff. It is 50 questions, 35 of them being multiple choice, and the remaining 15 open-ended, including graphing.
Can we get half credit on the open-ended?
Yes, you can get partial credit on the open-ended, yep. You have, I think it's an hour and 45 minutes, like from the time you walk in till the time you leave. I would say you'll get a good chunk of that, like we used to do prayer and pledge and stuff like that at the beginning of the day, but then you'll get a good chunk of that time to take the test. If you know you like are a finish early kind of a test taker, bring something that is a physical thing to keep you occupied, whether that's a book or, you know, a pillow so you can take a nap. I don't care what you do with that remaining time, okay? But it won't be spent on an iPad. So keep that in mind. Yeah.
So I come in like I work 7.
So I is first. You'll come the regular time. Like class starts at 8:05 still. Yeah, but then you're done at, right? Is it 9:45? I think that's the time frame on it. Yeah. And then if you take J, you have a time like a 20-minute block in between. If you don't take J, then you get to go home. Yeah. Yeah. All right, so I'm gonna, again, I opened up the packet. I would recommend that you do the same. Even if you are thinking you're exempt, right? There's absolutely no harm in reviewing math. Everything that we covered this semester, you will cover again next year. It doesn't go away. So it is one of those things that, you know, obviously when you're sitting at home bored, but I hate for you to have nothing to do, you can spend some time doing your math review, okay? In chapter P, this was adding, subtracting, multiplying polynomials. Because we've done this stuff so many times since, hopefully this is like, oh, this is super easy, okay? Because you've literally continued to multiply, expand, use your special products, all that stuff. All of that came from chapter P. That continues on page 2 into factoring. So factoring will literally be all of the factoring combined. It could be difference 2 squares, could be greatest common factor, it could be perfect square trinomials, it could be perfect cubes, right? Like all of that stuff is factoring. That was P4, I think. Like we split up like into like 6 sections, but I think that was all P4. If you need to go back and you need to review that stuff. Then came at the top here, multiplying, dividing, adding, and subtracting rational expressions. So whether you're factoring and seeing if you can cross cancel, or keep change flipping and then doing the same thing, or finding the least common denominator on the bottom there and changing them so they have it. This is all still chapter P.
Question?
Yeah.
Will the final include everything?
No. I mean, you're going to still have some stuff built into it, but no, your final will start from January's lessons to the end. Yep.
That's good.
Then came all the rules of exponents, right? So like if you have a negative exponent, it moves to the bottom. If this was 2 to the negative third, this would become 1 over 2 to the third, which is 1 over 8. If you are multiplying with exponents, like an x to the third times an x to the fifth, we add the exponents. When we raise to a power, we multiply the exponents. So all that stuff's going to happen in there. If I raise to the 0 power, what happens?
Becomes 1.
Yep, anything raised to the 0 power would be 1. Then came simplifying your square roots. So whether that's breaking it down using the factor tree or expanding and foiling, like number 90 and 91, you're distributing there. And then we had our dividing where you're rationalizing. So you're multiplying both the top and the bottom by the opposite of the bottom so that you can get rid of your square roots. Then came chapter 1. So it started basic, solving equations. Remember your special cases. If everything cancels out and it's true, it's all real numbers. If it cancels out and it's false, it's no solution. Then you got into your complex numbers. So with these, we treat the I as though it is just a variable, except if it is squared, that becomes a -1. With something like 29, you're going to have to multiply by the conjugate, which would be 2 minus 5i in both the top and the bottom. That was called the conjugate. Which is same expression, opposite sign on the I value. Your higher exponents with your i's, remember if it's even, and then we divide it by 2 and it's even again, then it's a +1. If it's even, but after we divide it by 2, it's odd, then it's a -1. And if it starts out odd and we divide by 2 and it's even, then it's a +I. Divide by 2 and it's odd and it's a -I. So you can either divide it out, like if I took that 6, so let's say it was I to the 603, I would break that apart as 602 and then an I. 602 divided by 2 would be 301, which means there's going to be a negative amount. So this would be then squared. Negative squared, which means this is a -I. Or you use that little trick. If it starts out odd, and then I divide by 2, and it's even, or sorry, and then it would be odd. That 301 would be odd, so then it's a -I. So you can do either one. Then came your quadratics. So you either factored, used the even root, or used the quadratic formula on these. So something like 37, I would say it's set up easier to do the even root, square root both sides, put that plus and minus. But then something like 29 or 39, I would check to see first if I could factor it, and then if not, use the quadratic. Questions on that stuff? Yeah.
I have a question. So, not the last chapter, the chapter where you're doing like the radicals and you're squaring it, is that going to be on the midterm wall?
The long, really bad ones? No. No. Yeah.
Interval notation.
Interval notation you'll see.
A lot.
And nothing's a lot. But you're definitely going to see interval notation because it's in the increasing, decreasing, it's in the domain and the range, and it's in your interval, your inequalities. So like summer, you're talking about this stuff at the bottom.
Yeah.
Yeah. Like there's not a lot. You might get 1 or 2 of them. There's a lot there to practice because they're all different kinds. But the ones where you have to like a 77 where you had to move it, square it, and then end up squaring it again. Like there's only one like that's even an option out of those 6. And I think from this section, there's maybe 2. Yeah. So these were like all those other types of equations. This was the bad stuff. This was the either using your rational equations. So you got fractions going on there that you had to find the least common denominator. And then that was the rough quiz or test, whatever that was that you guys had. You can either use your substitution, like for 71, I would make that a squared plus a equals 6, like that kind of a thing. That's the easiest way to do it. But then you got your radicals. And remember, anything that started out with square root, those are the ones you would check. Then came your inner inequalities, and this is where the interval notation comes in. So you'll get these kinds of questions. For 83, 85, 87, you're just solving. But 89 starts to be quadratic, so this is where your test points comes into play. On your number line where you have to solve it, plot your point, and then plug in and see from which of those works. And then you got 99 like 97, you got to get it to one side, combine it into one fraction. after I'm done with this. Well, you'll get it. I'm gonna still have to take them back, but I'm gonna give them to you. Yes. All right, then there was more complex numbers. Well, wait, first at the top was their absolute value. With inequalities, remember if it's a less than or equal to, it's an and statement. If it's greater than or equal to, it's an or statement. Or you can also just solve it and then test your points. You can do it either way. These will be answered in interval notation as well. Then came complex numbers again. So these are just some extra practice on the complex numbers. Really, that's grouped together with the last one, but just some extra practice. Okay, then came all the graphing stuff. So this is where I need you to add to the top of this, because these directions just say find domain and range. But you also have to know how to identify increasing and decreasing behavior from graphs. And to determine if something is a function based on a graph. So this would be vertical line test. You'd have to be able to tell if something is a function based on points. So the rule is that the x can't repeat with a different y. And from an equation, and the rule is that y can't be raised to an even exponent or an absolute value. So those examples are not built in here. I will try to find some extra practice on that stuff so that we could do it either Thursday or next week when I see you again. But you definitely need to make sure you review that stuff because it's not in this packet.
So wait, from equation, what does that stand?
Like your y can't be raised to an even power or an absolute value. So if it was just asking if something was a function and you had like y equals x squared plus 3, that is a function, but x equals y squared plus 3 is not a function because the y is raised to the even power. Yeah.
Is Thursday a full school day?
Yeah.
I thought it was a review day.
It's called a review day, but it's a regular day. Thursday's your last full day.
Okay, so but then the rest is...
The rest are noon dismissals. Yep.
Fridays are these?
Yep, because it's just A and C. I think that's it on this page. Okay, and then comes at the top of this domain from your equations, which that was like on yesterday's quiz too, so hopefully that's still kind of fresh in your mind. And then your function notation, all your f ofs. 38 through 47 are all graphing, so those are all graphing your lines. Finding the equation of a line and finding the slopes of the lines are all things you have to review. We're gonna, like I said, I'll generate some extra practice on it because it's also not on this, but graphing your piecewise functions, like if I gave you f of x equals, and it said x plus 1, where x is greater than or equal to 3, and x minus 4 if x is less than 3, you would need to know how to graph that. So if you want to add that on there, I don't even know what page I'm on. I'm on the bottom of page 10. No, page 9. Yeah. Make sure you know how to graph your piecewise functions. Then came finding the equations of lines. So you can either use y equals mx plus b, or you can use the point slope, which is y minus y1 equals m times x minus x1. Remember, parallel have the same slope. And perpendicular, opposite reciprocal. If the equation is given to you in standard form, then the shortcut for slope is negative a over b. Okay, if you don't remember it, obviously you would need to just solve for y, but you can use that shortcut. And then came graphing using transformations. So this is your shift up, down, right, left, reflected, that kind of stuff. You'd need to know how to describe that in multiple choice format. Like if it said, what's the difference between f of x and g of x? And it is that it's shift it to the left 3, up 1 like that, and then also know how to graph it. So this is absolute value, but you want to make sure you know how to graph an x squared or a square root of an x. Okay, then the rules on symmetry. So remember, if it is, so the rule on symmetry, because these are not just functions, the rule on symmetry for y-axis symmetry, you plug in negative x, and if it goes back to the original, or each sign changes, then it's got symmetry to the y-axis. So this is different from when we did it before, because when we did it before, it was just functions. Then for x-axis symmetry, you plug in a negative y. And if it goes back to the original or each sign changes, then it would have x-axis symmetry. And then the last is origin. And for this, you plug in a negative x and a negative y. And if it goes back to the original or each sign is the opposite, then it has symmetry to the origin. So that's a little different than when we went over it, because when we went over it, it was functions, and functions would not be symmetric to the x-axis, and they had f of x. So you have to do it a little bit differently when you're dealing with symmetry, right? This was the same thing as even, odd, and neither, except that those were only for functions, and this is not just for functions, this is for anything. So 93, 94, 95 is what I was talking about before, where it said, like, you might have to describe it in words. So it could be reflected, it could be shifted down, it could be shifted right, it could be vertically stretched or shrunk. And then the bottom is back to 2-6. So adding, subtracting, dividing composite functions, finding the domain of them. That stuff was literally on yesterday's quiz. This is still 2-6. Yep, and then 3.
Are there 2 parts of it?
No. This is still that same document, right? I opened it from yours. Yeah, should be the same document. Yeah, because that's it. 2-6. We didn't even get to chapter 3 yet. Chapter 3 is your quadratic stuff. These are your parabolas. So this would be finding the vertex, the axis, the x-intercepts, y-intercepts, domain, and range. It will not force you to put it into standard form, so you're not going to be forced to complete the square. You get to choose if you want to use that complete the square, if you want to do negative b over 2a. But just be prepared to answer all that information again from it. Like, it could be just one point. Just give me the vertex. Just give me the domain. Well, it won't be just domain. It would be like, just give me vertex, or just give me domain and range, maybe like that. And then we did synthetic division in a couple different ways. One was actually just dividing it out. One was using it with the remainder theorem to find f of something. One was to determine whether it's a 0. So here you're looking for if the remainder is 0. And then came finding rational zeros of a function. So this is that 3, 4, where you have to build your possible bank because it's not going to be factorable, and then test them out. There's not going to be like a million possibles. If you look, like, those numbers are both prime. So they're not awful, and I would start with the whole numbers and see which ones work, and then use the remaining. And then 41, is it a factor? Again, you're looking for a remainder of 0. Summer.
I have a question on like the one in synthetic division.
Yeah?